This program was designed to lead students through the process of building and calibrating a scale using simple equipment that could be found in most physics labs. Students can do the lab entirely virtually, or they can do it both virtually and live, which is my suggested route. Okay, so students would gather the materials they need. They would start out by taking one of the hanging clamps and securing it at the 15 centimeter location. The exact spot is not critical. The important thing is that once they secure the clamp, it does not move for the remainder of the lab. They then take the support clamp and they put it somewhere near the 50 centimeter mark. The exact position will change in just a minute, so it's not important that they get it at the 50. They then put the support clamp on the support stand, and the system will not be balanced even if they're at the 50. They then have to find the balancing location by sliding the support clamp until the ruler becomes horizontal and stays in equilibrium. At this point, we can now ignore the mass of the meter stick and the mass of the two clamps as long as both clamps remain in the exact positions they are at the end of step 4. Okay, so then we move on to step 6 where we add a second clamp. That goes somewhere on the right hand side, maybe around the 70 centimeter mark. This will knock us out of balance, which is fine. We don't want to do anything to change that. Then we want to put a counterweight on that clamp, which will make us even more out of balance. Then we want to put on a known mass, and we put the known mass on the clamp that is at the fixed location. The counterweight will remain the same weight the entire time, but it will go to different locations. So that's the clamp you want to move. You move it until you find the spot where the ruler returns to its horizontal rotational equilibrium. In this instance, the clamp has to be at the 87.9 centimeter mark. So students would write down the mass, 300 grams, and the location of the counterweight, 87.9. They would then repeat this with other masses. Again, the counterweight doesn't change. You change the mass that's on the fixed location clamp. So we change it to a 200, a 250, a 100, and a 150. When students are doing it live, I would suggest at least 5 different masses, but it would be even better if they did 10. Once the students have collected 5 to 10 data points, again, mass and location of the counterweight, they will then graph out their data. They should get a linear graph, and when they fit their graph, they will get the equation that is their calibration equation. Location is equal to 0.1420 times the mass in grams plus 48.58. Students will use this equation to then figure out the mass of an unknown object. So they'll place an unknown object on the clamp that's at the 15 centimeter mark. They'll find the balancing location for the counterweight, in this case 68.9. Then the students will use the equation that they got to figure out the mass of this unknown object. If they did everything right, their data should be really good. They type their unknown mass into the box along with their name, and then they will submit it. If they get it right, they'll get a certificate saying that they did it correctly. If they get it wrong, they'll be urged to try the process again.